Welcome, friends, in today's session on Monte Carlo simulation. This session is especially designed for the students of CA, ICWA, MBA, BBA, and BBM students. As you know, simulation is the most important tool in operations research used to predict the future behavior of the events. The first question may arise in our mind that what is simulation? Simulation is to imitate, means to copy a real world situation or phenomena in artificial environment and then making experiments on the model evolved. The best part of this model is that it provides the descriptive outputs of the situation. It is not like the LPP or transportation or assignment which provides the solution for the given problem. It provides the detailed information that what could be in future. In it, the model is copied from the real world along with the variables and constants associated in it are manipulated in artificial environment to examine the behavior of the system. Now, we can divide the whole process of simulation in basically four parts. In the first part, we define the problem and state the objective in clear terms. In the second phase, we construct an appropriate model to replicate the real world scenario. In third phase, we go for the experimentation with the model constructed. And in the fourth phase, we evaluate the results provided by the different situations which we put in our model. And by that way, we select the best course of action. We are going to discuss Monte Carlo simulation. It is also known as computer simulation. In this technique, the stochastic systems are developed to predict the system's behavior. In it, the chance element is the most significant feature, and this approach can be used when the given process has a random or chance component. We can briefly divide all these steps of Monte Carlo simulation in five phases. In first phase, first of all, we have to select the event for which we have to make prediction or for which we have to simulate. In the second phase, we have to collect the past data about that particular event. This data will help us to calculate the probabilities associated with the different events. Many a times, the frequencies of the past data are given. So with the help of frequencies, we calculate the probabilities. In third phase, with the help of probabilities, we calculate cumulative probabilities. And in fourth phase, with the help of cumulative probabilities, we calculate random number interval. And at the final stage, from the random number table, we select the random numbers blindly from any point, making sure that we will not break the series. And with the help of these random numbers, we select the outcome of the event from the random number interval table which we had drawn at step 4. Nothing to worry. We will discuss all these things with the relevant examples. For instance, there is a bakery and we have to simulate the demand for the cakes for the next 10 days. And past 200 days sales information is given to us. That is the demand of the cakes along with the frequencies of that demand. Like this data shows that there was a 5 cakes demanded on 4 days out of 200 days. Likewise, in the first phase, now the work start. This is now we have to demand, we have to predict for the demand, and demand past data is given. With the help of this data, we calculate the probabilities. That is simply just by dividing the number of days divided by total number of days. Once we got the probabilities, we go for cumulative probability. Like for the first, we will go directly go for 0.02. For second, 0.02 plus 0.05. That's 0.07. And so on. That is, we are going to add the current probability of that particular event with the previous cumulative probability. Now, random number interval. We are going with the random number table which has the 2 digits. So directly we start with the 00, making sure 1 digit prior to cumulative probability. That is from 00 to 01. For next 02 to 06. Next 07 to 14. Likewise. And at the end we will be going till 99. If you are doing the things correctly, your last will be always 99 and the beginning will be always 00. By this way, we have created the random number interval table. Now, we have to make prediction for 10 days. These are the 10 days. We have taken the 10 random numbers directly from the random number table. You can directly go to the random number table and you will find out. Now 61. 61 will lie between 40 to 70 in random number interval. That is, the demand will be 9. 74. 74 will lie between 71 and 89. The demand will be 10. That means the table which we have created earlier, the random number interval table, there we will see the random numbers and we will predict the demand for the same. Okay. With the help of this, we have calculated the we have created the demand for the next. We have predicted the demand for the next 10 days. Okay, there's another example. Now we have created the scenario. You can say that in the different scenario. Dr. Strong is a dentist who schedule her patients for 30 minutes appointment. Some of the patients take more or less than 30 minutes depending upon the type of dental work to be done. The following summary shows the various categories of work, their probabilities, and their time actually needed to complete the work. We have to simulate the dentist clinic for 4 hours and determine average waiting time for the patients as well as idleness of doctor. Assume that all the patients show up at the clinic exactly their scheduled arrival time starting at 8. That means we have to predict for next 4 hours starting from 8 a.m. in the morning. And we have to use the following random numbers. The categories were filling, crowning, cleaning, extraction and cleanup. And the time required for these activities are also given along with the probabilities. So first and foremost work is to go for random number interval table. Show between 40 to 54. That means 60 minutes. So we have taken 60 minutes time. And with the help of the random number interval table, we find out this time. Now, here our work start. First patient come at 8 a.m. and he took 60 minutes time for his services. That means he will be out at 9. First patient has come at 8 but he is out at 9. Next patient has come at 8:30 but by that time doctor was busy with the first patient. So his service will begin at 9 a.m. once the first patient will be out. And second patient will require 15 minutes time. That means he will be out at 9:15. But third patient has come at 9. Doctor was not free at that time, so he will wait for 15 minutes. And his work require 45 minutes time, so he will be out at 10 and so on. By this way, we calculate the waiting time. Waiting time means when the service begins and when that patient has arrived. This patient has arrived 8, work start at 8, no waiting. Second patient come at 8:30 but work start at 9. It means he will wait for 30 minutes and so on. And in none of the case doctor was free. So overall waiting time is 285 minutes. There are 8 patients, so we can say that the average is 285 divided by 8. Similarly, for the idleness, there is no idle time for the doctor. I hope you understand the concept of simulation by this way. Okay, taken all these examples from the one of the renowned book of quantitative techniques in management by Andy Vohra from McGraw-Hill publication. I wish a great day to all of you, and I will bring these kind of videos in future also.